All right, let's look at the cylindrical coordinate system, right, and its volume element. All right, so before that, let's look at the Cartesian coordinate system. All right, so if you want to find the volume element, just like before, we say, okay, so here's a little piece of x, and here's the little piece of y, so dy. Here's the little piece of z, so dz. Right? So we can see that this is going to look like this. Let's see. So just like the polar coordinate system, the rectangular coordinate system. So you have that, but you're gonna actually go up. Let's see. So what's the best way to draw this? And maybe I should just draw a box here. Hopefully, it's kind of tough to draw a three-dimensional picture, but hopefully you can visualize this. And here, and this is going to be right here, and that's going to be right there. And let's see, like that. Alright, it's getting a little bit messy, but should be fine. Right, so you can see that, let's see, I'm looking at this box right here. Alright, maybe I'll put that little thing here. Right, then I'm just gonna paint it. So yeah, I'll just paint it here. How about that? Right. So this represents the visual image of volume element. Right. But since it's just a box, so the volume is just going to be dV. It's going to be simply dx times dy times dz. Right. So that's the volume element. So this is the volume element. Right. Can we do the same thing with the cylindrical coordinate system? Right. So conversion is x is r cosine theta, y equals r sine theta. This is really exactly the same thing as the polar coordinates, but since it's a cylindrical, so it's a three-dimensional, so we added the z component. So, but the z is equal to z. Right. So what would be the volume element for cylindrical coordinates? Right. So we do the same thing. So it's going to be r and theta and z. So we have a little bit of theta. So I'm going to draw it like this. Right. Then so that will be our d theta. Right. And the r is going to be, say here, I'm going to say from here to there. And this is going to be our dr. So you would have, again, kind of a part of the pie shape. So which looks kind of like, looks like that, right? But this has a height, so you have, let's see, hopefully I can draw this up here. So and they go kind of like this. So that's going to correspond there. That's going to correspond there. And like that. Like that. Alright, so you can see that, so that's going to be the little bit of a little piece of z, so I'm going to call it dz. So the object looks like it's going to look like this. Alright. Alright. right? It's like a portion of a cheesecake, like that, right? So I'm gonna just paint it so that you might be able to see it better. So it's gonna look kind of like this, right? And here. Alright, just like before, we pretend that this is going to be a kind of a square box. So the lengthwise here, it's going to be, so this is going to be dr, so that's not too bad. And just like the polar coordinates, this portion is going to be a r d theta, right? And the height here, so this portion is going to be just dz, right? So the volume element, so volume element for this guy, so dv is going to be multiply all together, so it's going to be r d theta dz, right? So that's the volume element for cylindrical coordinate system, right? That's it. I hope that this was clear.